All right, today we're talking momentum and conservation of momentum specifically. Hopefully what you've garnered from momentum is that momentum itself, momentum equals mass times velocity. Another major concept that you need to know about momentum is that momentum is conserved, which means when you have a collision, momentum will be transferred from one object to the next, either completely, if we're talking about situations like we do, where the first object stops entirely and the second doesn't, or sometimes partial momentum will be transferred when both objects are moving after the collision. And you'll see one of those for an extra credit question on your test. In either case, you should have an understanding of the idea that if momentum is conserved, I know momentum from first situation is going to be equal to the momentum of the second situation. So right now, our momentum of the first situation is, if we're talking about Tommy riding a bike at 2.5 meters per second, he and his bike have a mass, yada yada, his brakes snap, and he runs into Billy that's standing on the sidewalk. So at first I'm worried about the momentum of Tommy, and in the second situation I'm worried about the momentum of Billy. And this is because both of them happen to exist in scenarios where the other one's not moving. Realistically, this scenario one would be Tommy moving plus Billy standing still, but the Billy standing still is zero. In this situation, it would be Billy moving, but then Tommy on the ground because he just fell off his bike, and the Tommy would be zero. So in either case, the equation that we're really trying to use, because in order to solve for momentum here, we're going to do mass times velocity. M1v1, the initial mass and the initial velocity, are going to be equal to whatever this final one are, because this initial momentum is going to be equal to final momentum. So M2v2. Alright? And so let's sort this out. Let's get Tommy's stuff right off the bat. We know we're traveling, his bike's traveling at 2.5 meters per second, 2.5 meters per second, and him and his bike have a mass of 120 kilograms. And I should not have written in yellow. Multiply those two together, get a nice little 240 plus another 60, 300 kilograms times meters per second, if my mental math serves me right. And we know that that whole thing is going to be very useful because we now know that this is the total momentum that Billy has when moving. Okay, so let's figure out the whole Billy side of it. Assuming Billy has a mass of 75 kilograms, what rate? So with what rate means that we're solving for velocity 2. Mass 2, Billy is going to have a mass of 75 kilograms. So 75 kilograms times V2. And in order to solve for V2, we're going to divide out this side, 75 kilograms, by 75 so that they cancel, and then this side is going to get divided by 75 kilograms. And that gives us a nice little V2. Final answer 300 divided by 75 equals 4 meters per second. So Billy ended up flying away at a greater rate than Tommy came in because Tommy had much more mass than Billy's 75 kilograms. Okay, so your final answer there, 4 meters per second. Moving on to our second set, we've got Jane and her basketball. So Jane got her 2-kilogram basketball stuck into a tree. Her friend Robert is trying to knock it down with a football. He throws a football with a mass of 1.5 kilograms, traveling at 8 meters per second at the basketball, and hits it directly. Assuming that the football stops on impact, what is the momentum that the basketball will have as soon as it starts to move again? So we know that we've got momentum 1 is going to be basketball. And I lied here. The basketball is the thing that's blank. Yeah, it really doesn't matter either way, actually. We'll call P2 the football. Now, as you could tell a second ago, I kind of hemmed and hawed for a second because the football is the thing that's moving first. Does it matter which you list first? Not entirely. It's the same math either way, as long as you understand enough to know that these two are equal and that when you set this up, this is going to be M2V2, and you are putting your numbers in for this thing because the basketball is stuck in a tree. It has a 0 momentum because it is not moving just yet. Okay. So when we get into the second scenario here, if the football here happens to be, what do we got? 1.5 kilograms. As we see right here, football has a mass of 1.5 kilograms, traveling at 8 meters per second. We know that the football simply has a momentum of 12 kilograms times meters per second. And in terms of the question, it's saying, what is the momentum the basketball will have? Well, if the football has that momentum and it stops on impact, the basketball is also going to have that momentum. So your full answer there is 12 kilograms times meters per second. In terms of our third problem, we work our way down to a kid shooting a Nerf gun at empty bottles. If the 0.045 kilogram Nerf dart is traveling at 35 meters per second, what's the mass of the bottle that is hit if it falls backwards at 2.1 meters per second? Well, let's start us off with P1, and let's try to do this correctly this time. P1 is going to be the first thing moving, so we're talking dart is going to be equal to P2, and this is bottle. And again, I would really, really hope that you fully understand what is going on in this situation. If I'm talking M1V1 equals M2V2, what we're really saying is that there is another mass here. We've got if this is the dart, you've also got a momentum of the bottle where P is equal to 0 kilograms times meters per second, because it's not moving yet. And then the same thing here, the bottle is this, but you've also got a situation where the dart is 0 kilograms times meters per second because it stopped moving. So I don't want you to forget that those things exist. We're just ignoring them in the math because they don't happen to be there. So again, kind of remember that they're there, but when we're doing the math, it's simply that M1V1 equals M2V2. Okay, so my mass of the dart is going to be our 0.045 kilograms times 35 meters per second for velocity equals 2.1 meters per second. And my mass is question mark. I don't have a clue what that is just yet. So in order to solve for this, 2.1 meters per second. In order to solve for all this, let's actually break this down. If I've got if I happen to take this 0.045 kilograms times the 35 meters per second, I end up with a 1.575 kilograms times meters per second in terms of momentum. And that's again equal to M2 times 2.1 meters per second. And then to isolate for M2, divide by 2.1 meters per second, divide by 2.1 meters per second. That cancels and that cancels. And I'm left with this gorgeous little M2 equals, what we got, 0.75, and we're talking about the mass, kilograms. So your final answer is that guy. The mass of that bottle is going to be 0.75 kilograms, which is still kind of a heavy bottle, to be fair. And moving your way down to the final question, Andrew running around a track. Work our way back to the clicker, scroll down. Andrew's running around a track. He stops, and his 75 kilogram friend, this is supposed to be a nice little his, 75 kilogram friend runs at 3.4 meters per second and tackles him. Assuming Andrew has a mass of 95 kilograms, what's the momentum of Andrew after his friend hits him? So, and again, we are assuming that Andrew's friend stops on impact. So we are starting off with P1 is Andrew. Actually, P1, the first thing moving, not Andrew, is the friend. P2 is going to be Andrew. Again, we've got the P1 equals M1 V1 equals M2 V2. But being that this is asking for, and let's really look at this, what is the momentum of Andrew? If I find either momentum, I have found each of their respective momentums. So as long as I have all the information to solve for this, it will equal and be the answer that we're looking for. So M1 V1, Andrew's friend, 75 kilogram friend, 75 kilograms, happens to be running at 3.4 meters per second. And I throw those into a handy dandy calculator, and I get a nice little 255 kilograms times meters per second. So when we're looking at the momentum, Andrew's friend has this momentum, and then when Andrew actually starts moving, Andrew is going to have that momentum. So what's Andrew's momentum after his friend hits him? 255 kilograms times meters per second. Now, if I was asking you to take it a step further and figure out Andrew's velocity, I would divide both sides by 95 to end up getting an answer of mass 2 would be, velocity 2 would be 2.68 meters per second. But again, this is taking it a step further than you actually need. In terms of answering this question, what number 9 is, that does it. Okay. So hopefully this works you through the conservation of momentum. I think the big thing that many of you need to keep in mind is that we are always talking about two objects. Okay, so if we happen to have a before, there's always one that's moving and one that's stopped. And then after, we're always going to have one that's stopped and one that's moving. We, for the sake of these questions, are ignoring the numbers and the formula for the stop and simply making sure that the conservation of momentum applies and that the momentum for this is equal to the momentum for that. Hope that makes a bunch of sense. If not, find the extra practice sheets.